Alright guys, sorry about that. Got cut off. So anyway, like I was saying, what we're going to do is we're just going to use the law of sines to find B. Doesn't matter which one we do, honestly. And then once we know that, we know the triangle sum theorem. They're all going to add to 180, so we can find C substantially easier. So here we go. I'm going to say that the sine of 78 degrees over 7, and you can probably hear my hot water heater there in the background, sorry about that. The sine of 78 degrees over 7 is equal to the sine of B degrees over 5. Alright, so when I cross multiply, I'm going to get that 7 times the sine of B is equal to 5 times the sine of 78. Then I'll divide both sides by 7, and I get that the sine of B is equal to 5 times the sine of 78 degrees divided by 7. Now remember, when solving for an angle, that's when we're going to use the inverse sine function in our calculator. So B is going to equal the inverse sine of this entire fraction. So let's just punch it in the calculator and see what we get. Alright, so we got second sine 5 times the sine of 78, and then we divide that by 7 and close my parenthesis, and I get about 40, what does it say? About 44 degrees. Alright, is what I found for angle B. So B will equal about 44 degrees. So, and then by the triangle sum theorem, all the angles inside of this triangle have to add up to 180 degrees. So 180 minus the 78 that I know, minus the 44 that I know, and I get that angle C up here will be 58 degrees. Yep, 58 degrees. Perfect. Alright, so I'm able to find all of the angles. And again, what makes this difficult is now we're applying this law of sines, law of cosine stuff to application problems, but also finding bearings, and that's what we'll look at the next part. Alright, so based on what we found before, alright, in that last part of the problem, this was 78 degrees. This was, what, 44 degrees, and I think this was 58, but let me double check. Yeah, that top one there, that angle C was 58 degrees. Alright, so the last part is the bearing part. If you were on island A, so here you are standing on island A, on what bearing would you need to travel to go to island C? Well, remember, bearings, you always start at 0. So how many degrees clockwise do I need to rotate before I'm on this path that takes me to island C? Alright, well, I know that both of these two angles are complementary. They add to 90. And if this is 78, then that will be 12 degrees. So what bearing I would need to travel is just on a 12-degree bearing. Alright, what if you were standing on island B? What bearing would you need to navigate to go to island C? So this time, remember we start at 0 and we rotate clockwise. This is 90, this is 180, this is 270. So if I rotate around, I know you can hear the hum of my hot water heater, sorry. This is 90, 180, 270 plus 44 more degrees. So 270 plus those 44 degrees that are inside of that triangle, and 270 and 44 gives me what, 314? Better double check, it's early still here. Yep, 314 degree bearing. So from here all the way around is 314 degrees. So that'd be a bearing of 314 degrees. Sweet. Alright, and then the last problem. Jake goes in the backcountry, try to find Big Bass Lake. Jake was a student I had, last year, and he was big into fishing, so wrote this problem in his honor. Alright, a hidden lake that supposedly has the biggest bass in the country. On the first day, he leaves from the trailhead. So here's the trailhead, and he leaves on a bearing of 70 degrees. Now remember, this is 0 degrees north. He rotated 70 degrees clockwise, which is before you get to due east, which is 90. So how many degrees are left right here? Would be 20 degrees. Because 70 and the 90, or 70 and the 20, are complementary from my north line of sight and my east line of sight. So that bearing of 70 leaves 20 here. All right, let's see. And he goes 10 miles to camp 1. Then he sets up camp. On day 2, he heads out from his camp on a bearing of 150 degrees. All right, so remember, starting at 0, and he's going on a bearing of 150, so this is 90, and he's going past 90. Well, how many degrees past 90 do you have to go to get to 150? 60 degrees past 90. Or how many degrees shy of 180 would that be? Well, that'd be 30 degrees shy of 180. All right, so using that bearing, starting at 0, a bearing of 150 degrees goes 60 degrees past 90, or 30 degrees before due south, which is 180. So I know that this angle is 60, and this little guy in here is 30. So he goes on that bearing of 150 degrees for 8 miles. Then he finds the lake. He camps there for the night and catches the biggest bass of his life. Let's see. After fishing, he needs to head straight back to the trailhead, draw a picture that represents the situation, filling in any angles and sides. All right, so here's what I know. I've got so far that this side length is 10. I know this side length is 8. That's all that was given to me. All right. In terms of angles, I know that this angle was 70. This little piece was 20 here. But I also recognize, and hopefully you guys remember this from when I did that first lesson, I have alternate interior angles. So look, I've got this Z right there, which means that this angle and this angle are congruent to one another, which makes this 70 degrees as well. So you cannot forget about your alternate interior angles. Here's what I've got. If this is 70, then this must be 70 as well. You can see that little Z. So that means in this entire angle is 100 degrees. And that's all I need to know for this problem, because the next part asks me to solve for the distance between these two. And I have side, angle, side, so I can use law of cosines. So draw the triangle, which I already did for you, with all the known sides and angles. So it was 10, 8, and 100 degrees between. This is 10 miles, 8 miles, and I figured out that this was 100 degrees between those two trails that he was hiking on. Use the law of cosines to determine how far the trailhead is from the lake. So remember, for law of cosines, it's this. And what we need to do is we need to have a side, angle, side situation. So side, angle, side, and then we use that to find this little loner dude all by himself. So in regards to filling in for what variable is what, I'm going to call this C, call this A, B, and big C. So here's what I know. I know that x squared is equal to 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of 100 degrees. So all I'm going to do is I'm just going to punch all of that into my calculator in one foul swoop here. So let me pull up my calculator and show you. So 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of 100 degrees. Oh shoot, I did 1,000. Hold on. Sweet. Alright, and I got that x squared is about 191 point blah blah blah. So I'm just going to write that down like 191.78 it looks like. And then all I'm going to do is I'm going to take the square root of that number. So second square root and that previous number, I don't want to round yet, and I get x is around 13.8 miles. So I found this distance. So you guys, here's the thing, right? You totally could choose a bearing and walk along in a straight line for a certain distance. Stop, choose a new bearing, walk along a straight line, choose a certain distance. And the cool thing is that this math that we've been doing the past couple of days is really applicable, and you can figure out how far you are away. We could go even further and determine, hey, what bearing does he need to travel to go from here to here? It just gets a little more complicated, and I believe this is probably good enough for now. So I know this is tough, and I'm begging you guys, reach out for help if you need it. I'll walk through every problem with you if you want in your assignment. But good luck. And again, this is it. This is the last piece of material. Next week, we're just going to review and take a test on Friday, and then we're all done. So we're done with the math part. I'm going to have you do something else, but we're done with the math after this. So let me know if you need anything, and I hope that made sense. I know it's not easy to explain things to you on the computer, but just try your best. And again, please don't hesitate to ask me for help. All right, guys, take care.